Hello, Sugar Gliders. Welcome to Chapter 6, Lesson 6. We're going to look at our fourth property of math, the distributive property. The distributive property combines addition and multiplication, and it can be helpful when we're doing mental math, when we try to do it in our head instead of using a calculator or paper and pencil. So our first example is 6 times 38. We're going to use the distributive property to do it mentally. I'm going to have to write it all down to show you what I'm thinking, but typically we would just be thinking all this in our head. So when we have 6 times 38, I'm going to break up this 38 into 30 plus 8. So what I did here was I wrote 38 as 30 plus 8. It still has the same value as 38. My next step, I am going to use the distributive property because I'm going to take the 6 that's on the outside of this parentheses, and I'm going to take the 6 times the 30, which I'm showing you here, and I'm also going to take the 6 times the 8, which I'm showing you here. So that's where we've just used the distributive property. So now I can look at this as two separate problems. 6 times 30 is 180, and 6 times 8 is 48. So I should have been able to multiply 6 times 30 mentally. So what I did was I multiplied mentally in my head. And then the last thing I'm going to do is add those numbers together. Okay, so when I add 180 plus 48, I can do it in my head. I know these numbers aren't the easiest numbers to do, but 80 plus 48 I know is 128, and then I tack it onto the 100 and I get 228. All right, let's look at the next example. Find each product mentally using the distributive property and show the steps you use. So 3 times 78. The first thing I'm going to do is write 78. Well, I don't want to write that there. I'm going to think this. Write 78 as 70 plus 8. So I'm going to do 3 times 70 plus 8. Now I'm going to distribute that 3 to both the 70 and the 8. So I'm going to think about this as 3 times 70. So I am multiplying the 3 times this 70, plus, I don't want to get rid of that addition sign, plus 3 times 8. And that came from this part, 3 times 8. Now I should be able to multiply mentally. I know 3 times 70 is 210, because 3 times 7 is 21, and then I have 1 0, plus 3 times 8 is 24, and I can add these easily in my head. 210 plus 24 is 234. Okay, the next one, 7 times 74. I'm going to write my 7 times, instead of 74, I'll break that up as 70 plus 4. Now remember what I'm going to do. I'm going to distribute the 7 times the 7 and the 7 times the 4, but I have to put an addition sign between those two. So I'll have 7 times 7 plus 7 times 4. Now I can multiply mentally. 7 times 7 is 49, plus 7 times 4 is 28. Now in my head I want to be able to do this. Oh, this should be 70, sorry. 490 plus 28. How do I want to do this? In my head, I'm going to be thinking, instead of 490, this is called compensation. I'm going to think about this as 500. So what I did was I added 10 to make 500 easier to add with the 28. So I know that's 528, but I have to take this 10 away that I added here. So I'm going to subtract 10 and get 518. Now I know we haven't gone through this mental math thinking. It's called compensation, just to make it easier. Add 10 to get it up to a nice round number, and then take that 10 away. You may or may not know what I'm talking about. We'll talk about it in class. All right, example 2. You can also use algebra tiles to model expressions with variables. So I know you don't have tiles in front of you, but I am going to let this long tile be an x, a variable that we don't know what the number is. And I am going to let this blue one represent the integer 1. Okay, so if you see that, that's a 1. All right, use algebra tiles to tell whether 2 times 2x plus 1 and 4x plus 2 are equivalent. Do those two mean the same thing? Well, let's take a look at 2 times 2x plus 1. This 2 means I have two groups of 2x plus 1. So I'm going to show you what 2x's look like. 2x's look like this. Here's 1x. There's 2x's because I said that's my model of an x variable. Then I have plus 1, and that 1 is simply an integer. So that's what that looks like. That's 2x plus 1. Now it says there's 2 of them. That 2 on the outside means I have 2 of those groups. This is my 2x plus 1 in the parentheses. I have 2 of those. So I'll do another one. 2x's plus 1. Okay, so that's what's inside my parentheses, 2 of those groups. Is that the same as 4x's plus 2? Well, if I counted them, if I put them all together, let me count. 1, 2, 3, there's 4 x's, just grouping them together differently, plus there's a 1 square, which is an integer 1, and another one, which is the integer 1. So does 2 times 2x plus 1 and 4x plus 2, are they equal? Well, here's 4x's plus 2. So the answer is yes, they are equal. So those two expressions are equivalent. So we get to visualize what that would look like using algebra tiles. All right, let's look at another example using algebra tiles. Tell whether 3 times x plus 1 and 3x plus 3 are equivalent. So let's remember, an algebra tile, this would be an x, and one little square would be the number 1, integer 1. So here, this means I have 3 groups of this. Okay, so my first group would look like this, x plus 1, and it says I have 3 of those, so I'm going to make another group of that. An x plus a 1, so there's 2 of those groups. And then my third group would be an x plus a 1. Okay, so this represents that. And let's see, is that expression equal to 3x's plus 3? So if I were to draw 3x's, my x's look like that. 1, 2, 3 x's plus 3, the number 3, here's the integer 1, 2, 3. So if I looked back and counted, I can see I have 1, 2, 3 x's on the left, 1, 2, 3 on the right, and 1, 2, 3 blue integers on the left and 3 on the right. So yes, they are equivalent. All right, now we have a visual using variables. Let's take a look at the distributive property to rewrite 2x plus 3 without our tiles. So if we were to distribute this 2, we can say 2 times x plus 2 times 3. That would equal 2x plus 6 after I've multiplied that out. Okay, let's take a look at the second example. Use the distributive property to rewrite each expression. So I want to distribute 8 times the x, so that'll be 8 times x plus 8 times the 3, so 8 times 3. If I were to work that out, 8 times x equals 8x plus 8 times 3 equals 24. And then the next one, 5 times 9 plus x. So again, distribute the 5 times the 9 plus distribute that 5 times the x. Multiply it and we get 5 times 9 is 45 plus 5 times x is 5x. All right, let's take a look at a word problem. Fran is making a pair of earrings and a bracelet for 4 friends. Each pair of earrings uses 4 centimeters of wire, and each bracelet uses 13 centimeters. Write 2 equivalent expressions and then find how much total wire is needed. So let's take a look back at our problem and see what we need to pick out. So Fran's making a pair of earrings and a bracelet. She's making these for 4 friends. Each pair of earrings is going to use 4 centimeters of wire, so the earrings are small, and each bracelet is going to use 13 centimeters of wire, so the bracelet's bigger. The problem wants us to write 2 equivalent expressions and then find how much total wire is needed. So it looks like I'm going to have 4 of something. Okay, and I'm going to group together the wire. There's 4 friends she's making the necklaces, or not the necklace, the earrings and the bracelet for. The earrings take 4 centimeters, plus she also needs wire for the bracelets. So 4 plus 13 tells us how much wire she needs for one friend to make an earring and a bracelet, times the 4 means there's 4 of those she has to make. So if I distribute these, 4 times 4, that's 4 friends are getting 4 earrings. That's how much wire it's going to take. And then 4 times 13, 4 friends are getting those bracelets, and it's going to take 13 centimeters. I should get the same answer on each side. So if I did it on the left side, I'd have 4 plus 13 is 16. And what is 16 times 4? It is 64. So she needs 64 centimeters if I looked at it this way. On the other side, I would say 4 times 4 is 16 plus 13 times 4 is 52. And 52 plus 16 is, 68. What did I do wrong? I wonder. 13. Oh, I know why. Because 4 times plus 13 is not 16. It's 17. I found my mistake, which is good. I noticed I did something wrong. So everyone makes mistakes, and I checked my work. Now I can see where I can correct it. Okay. All right, why don't you try to do number 4 on your own and come back in class, and we will talk about that tomorrow. Have a great night.